Okay, we've just configured the servers. Now, let's configure the target groups. I'm going to lead it at instances, and I'm going to call it TG1, followed by the protocol that the target group will serve, in this case, FTP. Next, we can configure the protocol and port for the listening agent to match the incoming traffic. Note that the options you see here are for all types of load balancers, not just the network load balancer. So, how this target group will serve FTP traffic? We will set the protocol as TCP and the port number as 21. Next, I select the VPC where the instances are hosted, and in health checks, I will set the protocol to TCP. Leave everything else like this for now and press Next. Here, we must add the servers to this target group. We just select them and add them. Notice that the port number is 21 because they were both configured to serve with FTP as well. We create the target group. And now, we repeat this same process. But this one will be called TG2HTTP. For the listening agent, we are going to set the protocol as TCP instead of HTTP. This is because HTTP is not a protocol supported by the network load balancer. Network load balancers work at the transport layer or layer 4 of the OSI model, which includes TCP and UDP, while HTTP is an application layer protocol or layer 7 protocol. If you select HTTP port 80, this target group cannot be used with a network load balancer. So, we will set the protocol to TCP and the port number to 80. Then, I select the VPC. Next, select both servers and add them since they were both configured as web servers on port 80 as well. Create target group. And it's done. Let's review some details. Up here, we see information such as the target type, in this case, instances, the port, the VPC. We can also see the distribution of the availability zones, and at the bottom, the targets that are currently not in use. We can see some monitoring, health checks, and another thing I want to show you is here in attributes. This first option, terminate connections when targets become unhealthy, refers to how existing connections are handled when a target, for example, any C2 instance, is considered unhealthy. If this option is enabled, any existing connections to that target will be terminated immediately. If it is disabled, existing connections will be kept open, but no new connections to that target will be allowed. For example, imagine you have a web application hosted on multiple C2 instances behind a network load balancer. This application handles critical financial transactions for your business. If one of the EC2 instances starts having problems, for example high latency or software bugs, the NLB will flag it as being unhealthy. Therefore, if you have this option enabled, all existing connections to that instance will be shut down immediately. This may interrupt financial transactions that were in progress, which is not ideal. On the other hand, if you disable this option, existing connections will remain open, allowing ongoing financial transactions to be completed. However, no new connections to the unhealthy instance will be allowed. This minimizes the impact on ongoing transactions and helps maintain the quality of service of your application. In addition, when you disable the option, you can configure the draining interval for unhealthy target, which allows you to control how long these existing connections are kept open before closing them. A value of 0 seconds would close the connections immediately, while a higher value would allow the connections to be kept open for longer. And here, in traffic configuration, we have proxy protocol VQ and preserve client IP addresses. The proxy protocol is a protocol used to forward connection information from a load balancer to a registered target. It allows the load balancer to pass details about the requesting client to the registered target, such as the source IP address and port number. Version 2 of the proxy protocol is an enhanced version that includes support for IPv6 and transport protocol identification, such as TCP or UDP. The following setting allows you to preserve the client IP address. This allows you to preserve the source IP address of clients when forwarding requests to registered target. If disabled, the network load balancer's private IP address is used as the client address. This is useful for preserving client anonymity and when user privacy is required. And already the last settings down here, we talked about in previous classes. So I will leave all this as it was, and we are ready to implement the network load balancer. See you next time.